Let us spend some time in another data structure, linked list. Let us start. Linked list is a linear data structure where items in it are stored sequentially. First, let us understand why we need this another linear data structure when array can give all the required functionality. The main problem with array is we need contiguous memory allocation before usage. It is not always possible to know the size before, and the collection size is ever growing in some cases. Let us think a bit. We can definitely achieve this by blocking some huge memory upfront. But blocking a big memory chunk without using is poor use of resource. Also, another important usage of removing item from a collection is not so easy with an array implementation. To address these issues with arrays, linked list is used. It is used mainly in dynamic memory allocation. Also, used as base data structure for implementing other data structure like stack, queue, hash table, graphs. Also, the building blocks of files system, that is folders and files, are another place where we use this data structure. As usual, let us start our discussion on operations supported in linked list. We have insert operation to add an element to the linked list. We have delete operation to remove given element from linked list. We have search operation to look up for an element in linked list. Let us see an implementation of linked list data structures. Let us take some time to go through the code. In this implementation, we created the basic unit of linked list called node. It has two fields, one called as data to store the data part of the item to be stored. Another one called next to store the location of the next item in the linked list. It will be pointing to none for the last item in list. We also created another structure to represent linked list. It holds an element called head to point to the first element in the linked list, because a linked list is always referred with a head pointer. Let us do our usual bit of runtime for the supported operations and space analysis. Like in other linear data structures, the space complexity is order of n as it does not require additional space. Let us get to the main part, runtime analysis. Repeating my regular statement that it depends on how the data structure is implemented. For our discussion, let us restrict our analysis to a doubly linked list implementation. Both insert and delete can be done in order of 1, while search operation will be in order of n.